what's going on in the Pacific. So we have an incipient El Nino event that is happening, though we anticipate that the impacts of that El Nino event are going to build over time as we get towards a larger event towards the end of the year. And the biggest impact of El Nino will actually occur in 2024. So we're anticipating that not only is 2023 going to be exceptionally warm and possibly a record warm year, but we anticipate that 2024 will be warmer still. There are other things going on beyond El Nino. We're seeing extreme temperatures in the North Atlantic and in other parts of the ocean. These have been building for a while. You would have seen some discussion of that since March. There's a persistence to the sea surface temperature anomalies that is helping fuel the warmth in July and through the rest of this summer. And one of the things that comes from that is because July and August are generally the warmest months of the year in the global mean, and that's because of the asymmetry between the northern hemisphere continents and the southern oceans. That means that this month is the warmest month in absolute terms in the record going back to the 19th century, though it isn't the warmest anomaly. So we've had bigger anomalies in February and March associated with the last big El Nino event in 2016. But what we're seeing here is the warmest absolute temperatures, and we know that that's having impacts. Kate mentioned it. We know that is inducing heat waves. We know that it is leading to more intense rainfall, and we're seeing that in many places in the world, and we know that it is a contributing factor to the growth of wildfires in areas that have been affected by the temperatures. Thank you.
Thanks a lot, Gavin. The oceans are experiencing about 90% of global warming. The last 10 years have been the warmest since the 1880s, and all these increases in temperature are not only felt at the surface of the ocean, but they can only be detected at thousands of meters depth. And there are consequences. As the oceans heat, the water expands, and when you combine that with the melting of ice over land, that contributes to increases in sea level rise, which are accelerating. And of course, the consequences are increases in coastal flooding, coastal erosion, and as an example, places like Miami Beach, they have been experiencing more frequent coastal flooding, only what we call, blue skies, about 5 times more than what they experienced 15 years ago. The marshes in Louisiana are disappearing also, in part also caused by the increase in sea level. Biology of the ocean also suffer consequences, right? These increases in temperature that we are seeing in Florida recently, with measurements approaching 100 degrees, exceeding 100 degrees in some areas, are bad for organisms. Not only are we seeing an increase in the frequency of coral bleaching, but we're also seeing coral, fish, and seagrasses die off. In other places like the East Coast, marine species of economic importance are migrating to colder waters. They're either moving north or going deeper. Unfortunately, coral reef cannot grow legs and move away, so they have to stay put and experience the brunt of global warming. To add some insult to injury, all this CO2 that we are putting in the atmosphere also dissolves in the water and acidifies it. The ocean waters are about 20% more acidic than at the beginning of the industrial period, and this is not good for corals. And many other microscopic marine species that are at the bottom of the food web are also affected by ocean acidification. Now, coral reefs are not just these pretty things that are there for tourists to go and look at them. They are super important for the marine ecosystem. About 25% of marine species have something to do with corals. They contribute with medicine. They contribute with livelihood to millions of people. They protect the coastline from tidal surges and storms. So they are key to the health of our marine environment. and they need to be protected. Fortunately, NASA, NOAA, and friends and family in other national and international agencies have been collecting crucial data to understand how the Earth is evolving under climate change. And more crucially, we continue to work in the development of advanced measurements so we can understand our planet even better. Next year, for example, we are planning to launch the PACE mission, which will provide unprecedented measurements on the biology of the ocean, not only to understand how it works, but how it will react to global warming. And simultaneously, it will collect measurements of the atmosphere so we can look at how this atmospheric ocean system works. We're working on the GLIMMER mission, which will provide very detailed measurements of our coastal environment, which are the ones that are feeling the brunt of global warming right now. And of course, NOAA is working on another mission like GeoXO, for example, which will provide continuity of measurements so in the future we can continue to study how our planet is evolving. And remember, these increases in extreme events not only affect the coast, they are also felt hundreds of miles inshore. So what happens in the ocean does not stay in the oceans. Okay? It affects the whole planet. So we continue to provide this crucial data so our decision makers, our policy makers can go ahead and do their job. Now I would like to leave you with Sarah, the Chief Scientist of NOAA, who will talk more about these issues.
Our data indicates that July 2023 was the warmest July on record for the globe. It was the warmest July by a long shot, specifically by more than 1/3 of a degree Fahrenheit. That may not sound like a lot, but the margin for most global records is on the order of 1/100th of a degree or two. So last month was way, way warmer than anything we've ever seen. The warmest month of the year for global temperatures is also typically in July, just like it's usually the warmest month of the year for most places in the United States. Given that July 2023 was the warmest July on record and July is the globe's warmest month of the year, it's very likely that July 2023 was hotter than any month in any year since at least 1850. Having said that, the really important thing to remember is that July 2023 is just the latest in a long run of extremely warm months and years going back several decades. In other words, the long-term increase in global temperature marches on and on and on. We have now seen 47 consecutive Julys that are above the 20th century average and 533 consecutive months above the 20th century average. It's also worth thinking about El Nino and its impact on things going forward, as Gavin mentioned. El Nino tends to increase global temperatures, albeit with a several-month lag, meaning it probably did not have much of an impact on this July record. Given NOAA's forecast right now, there is over a 95% chance that El Nino will continue through the winter. We could see even bigger impacts in the winter and spring as El Nino peaks. While El Nino might not have had much impact on air temperatures, it did contribute to the record-breaking global ocean temperatures. For the 4th consecutive month, the global ocean surface temperatures hit a record high as El Nino conditions that emerged in June continued into July. Over 40% of the ocean is currently experiencing marine heat wave, with our predictions showing that that could continue into the fall or even expand. Meanwhile, in the far south, Antarctic sea ice coverage ranked the lowest on record for the 3rd consecutive month, contributing to the July 2023 setting a record for the lowest global July sea ice extent on record. Putting all this together, 2023 to date has been the 3rd warmest on record. According to NCEI's Global Annual Temperature Outlook and data through July, it is virtually certain, over 99% chance, that 2023 will rank among the 5 warmest years on record, with a nearly 50% probability that 2023 will rank warmest on record. El Niños can temporarily warm the globe by approximately 0.1 degrees Celsius, an equivalent to the expected warming over a 10-year time horizon. A year like this gives us a glimpse into how rising temperatures and heavier rains can impact our society and stress critical infrastructure over the next decade. It's important to remember that these years will be cool by comparison by the middle of the century if we continue to warm our planet as greenhouse gas emissions continue. Put another way, the next few years will be the coolest for the rest of my life if the world continues to emit greenhouse gases into the atmosphere. Thank you.
Thank you all very much. We will now take your questions. You can press *1 to enter the question queue. Our first question is from Jim Siegel with NASATech.net. Jim?
Thank you for taking my question, and thank you for doing this session. I'm planning to do an in-depth story about climate change, and I'm curious about where I can go to get the base data from which the conclusions are derived that you described today. Is that in the is that in the database that Bill mentioned earlier, or what? And I'm kind of curious too about how far back reliable temperature data exists in the United States. Thank you.
Gavin, do you want to take that one?
Sure. So the data that goes into the GISTemp product is all available at data.gis.nasa.gov/GISTemp, and all of the data and uncertainties and analyses can be downloaded there. You can do the whole thing again if you want, but you can just get the answers if you want. The temperatures in the US are actually pretty well sampled, even going back to the mid 19th century, and so the CONUS temperatures go back easily to the mid 1800s. For other parts of the globe, it's not quite so well sampled, particularly in the southern hemisphere pre-1920. But we have a reasonable estimate of global mean temperatures going back. We cut it off at 1880. Our colleagues at NOAA go back to 1850, and there's another product from Berkeley Earth that tries to go back even further. But the uncertainties increase as you go back in time.
Thank you very much.
Thank you.
Our next question is from Rachel Ramirez with CNN.
Hey, everyone. Thanks for doing this. Administrator Nelson mentioned the fires in Hawaii, and, the death toll is climbing each day, so this isn't going away anytime soon in the news cycle. So I was wondering if we could touch on that a bit more in the context of the global climate records that you all just laid out. And I'm curious if NOAA or NASA is gathering more data in terms of kind of establishing that climate change connection with the fires, and are there any scientific initiatives also being affected by the fires on the ground in Maui right now?
Gavin has his hands up. And also Sarah.
Do you want to go to Sarah first?
Sure.
So this will be heavily studied. There will be a lot of research that comes out of both NOAA as well as our sister agency and Department of Commerce, NIST, who studies the wildfires and the effects of these things, in understanding specifically what caused this and the events that we've seen. Additionally, there was also drought present, which made it the dry conditions right in advance of it as well.
Thanks, Sarah. And Gavin?
Yeah, I mean, I think it's very important to note that when we have a disaster such as this, there are